بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 3.6 Implicit Differentiation. The aim of this section to describe the difference between explicit and implicit functions and to introduce implicit differentiation. So we have two types of function. The first one is explicit and the second one is implicit. Let us see what is the difference between the explicit function and implicit function. The explicit function is a function in which the dependent variable has been given explicitly in terms of the independent variable, or it is a function in which the dependent variable is expressed in terms of some independent variables. And it is denoted by y is equal f of x. So if you have a function y is equal f of x, this function is an explicit function. And here any explicit function can be written like y is equal a power x power n plus bx, where a, n, and b are constants. And the example of this one, y is equal 5x cubed minus 3. So the explicit function is a function of one variable. Let us see what is the implicit function. The implicit function is a function in which the dependent variable has not been given explicitly in terms of the independent variable, or it is a function in which the dependent variable is not expressed in terms of some independent variables, and it is denoted by rxy is equal to 0 or fxy is equal 0. And here we have some examples of implicit functions. For example, x squared plus y squared minus 1 is equal to 0, or y power 4 plus x cubed plus 17 it is equal to 0. So this one is an implicit function because it is function of two variables x and y. This one is an explicit function because it is function of one variable. We have y is equal. Here we have function of x, but here we have function of y and x. يعني الفرق بين الاكسبلسيت والامبلسيت فانكشن، الامبلسيت فانكشن انها تكون function of two variable فيها، اللي هي مثلا عندي fxy او rxy. فعندي هنا x square plus y square minus 1 is equal to 0. فهنا الفانكشن فيها متغيرين اللي هم الاكس والواي، ونفس الشيء انهم يكونوا مع بعض، او انه مثلا في الطرف الثاني نفس الشيء. هنا بيكون عندي مثلا x squared plus y square minus 1 is equal xy، فهذا نسميها implicit function. بينما لما تكون الفانكشن فيها one variable يعني y is equal اللي هي هنا function of x، هنا بنسميها explicit function. طبعا بعض الأحيان تقولوا إنه ممكن إن نحن نحول الإمبليسيت فانكشن إلى إكسبليسيت فانكشن، يعني هذه الفانكشن ممكن نكتبها بصيغة الإكسبليسيت فتتحول من إمبليسيت فانكشن إلى إكسبليسيت فانكشن. So let us try to rewrite this one as an explicit function. So we have x squared plus y squared minus 1 is equal to 0. We'll try to rewrite this one as an explicit function. This one is equal to 0, so this one is implicit function. We will try to rewrite this one and convert it to explicit function. So we need to write y in the term of function of x. So here y squared will be equal, move minus 1 to the other side, so it will be 1. This x squared is positive, so we'll move it to the other side, it will be minus x squared. So here we have y squared, so y that means is equal plus or minus root 1 minus x squared. So now we have y, a function of x. So we convert this one from implicit function to explicit function. But can we convert any implicit function to explicit function? So for this function, x power 4 plus x squared y cubed minus y power 5 is equal to x plus y. If we try to rewrite this function to put it in function of y, so for example, if we take this y here, move x power 4 there, so it will be x squared y power 3 minus y power 5, then minus y, this will give us 2x minus x power 4. Then if we take from here y common factor, so we left with x squared y square minus y power 3 minus 1. This will give us 2x minus x power 4. So we cannot rewrite this function as a function of x only, because here we have x squared, and we cannot take this x squared to this side. And also if we divide both sides by this bracket, we will have here a mixed function, which is function of xy. So this one is implicit, and once we rewrite it, we get also an implicit function. So we cannot rewrite any implicit function to the explicit function. Some of the function you may rewrite it and you convert it from implicit to explicit, and some other you cannot do it like that. Where y cubed minus y power 5 is equal to x plus y for y in terms of x, this will be difficult. We cannot rewrite this function and we cannot convert it from implicit to explicit. يعني لو بغينا مثلا هنا وفكرنا أن نحول هذا الامبليسيت فانكشن إلى explicit بيكون difficult، لأنه هنا لو نقلنا الواي بيصير بعدين هنا عندنا إيش؟ عامل مشترك، بيكون الواي مضروبة، فما ممكن نتخلص أو نجمع الواي في طرف ونخلي الإكس في طرف. أساس كده we have to introduce the implicit differentiation. So guidelines for implicit differentiation. Differentiate both sides with respect to x and treat y as a function of x. Then collect all terms of dy over dx in one side and the other side has all other terms. Then factor dy over dx for all terms containing this term, then solve for dy over dx. يعني أول خطوة بنشتق اللي هي both side بالنسبة لي الx. ثاني خطوة بنجمع كل الفاريبل اللي فيها dy over dx وبنخليهم في طرف والأشياء الثانية في طرف الثاني. آخر خطوة بناخد dy over dx common factor ونقسم على الفاكتور اللي موجود مع dy over dx. طبعا لو أنا عندي function of y وأشتقها بالنسبة للx بتكون مثلا عندي y power n is equal n y power n minus 1 لازم نضربها في dy over dx لأنه مشتقة الواي بالنسبة للx بتصير dy over dx. Let us simplify. Here we have some hint for finding the derivative of x squared, y squared, and so on. So here we have d over dx of x squared, we have d over dx of y squared, we have d over dy of x squared, and d over dy of y squared. So for the first one here we have a function of x, we differentiate with respect to x, the derivative of x squared with respect to x will be 2x. For this one we have dy squared over dx, so we differentiate y with respect to x, the derivative will be 2y, and we need to multiply it by dy over dx. Because this is a function of y, we differentiate with respect to x. In the same way, here we have d over dy of x squared. So our function is function of x. We differentiate with respect to y. So the derivative will be 2x multiplied by the derivative of x with respect to y. For this one, we have derivative of y squared. We differentiate with respect to y. So that means the derivative will be equal to y only. So if the derivative the function of the function and the variable of the derivative or the operator of the derivative, they are the same variable, so just we need to differentiate it normally. But if the function has a different variable than the variable or of the operator of differentiation, you have to multiply it by dy over dx. Similarly here we multiplied by dx over dy. يعني إذا كانت المشتقة اللي هي function of x إحنا نشتق بالنسبة للx بنسوي اشتقاق عادي فقط، بينما لو كانت المشتقة مثلا فيها متغير ونحن نجيب الديريفيتيف الفانكشن فيها متغير مختلف، إذا بجيبها اشتقاق عادي بالإضافة إلى إني أضربها في نفس ما سوينا هنا dy over dx أو هذه اللي هي dx over dy. يعني إذا كان الفانكشن والمشتقة بنفس الفاريبل بشتق اشتقاق عادي، إذا كان فيهم مختلف الفاريبل مختلف إذا اشتق اشتقاق عادي بالإضافة إلى أني لازم أضرب في المشتقة. First example, find dy over dx if x squared plus y squared is equal 4. So here we need to find dy over dx. Let us see how can we find this one. So here we have x squared plus y squared is equal 4. The first step we add the derivative d over dx to both sides. So this will be x squared plus y squared is equal d over dx of 4. Then for the second step we need to differentiate. So the derivative of x squared with respect to x, it will be 2x plus the derivative of y squared with respect to x, it will be 2y, and since this variable is different than this variable, so we need to multiply it by dy over dx is equal the derivative of 4 with respect to x, so here it is 0, so the derivative of any constant will be 0. The third step, we need to put the term that contain dy over dx in one side, so we'll move 2x to the other side, so here we have 2y dy over dx will be equal minus 2x. Then for the fourth step, so we need to write dy over dx in one side, so we need to divide by 2y, so dy over dx will be equal minus 2x divided by 2y. We can take these two with these two, so it will be minus x over y. So now we conclude that dy over dx is equal minus x over y. So this is the derivative of our function x squared plus y squared is equal 4. To find dy over dx, so the first step we need to add d over dx for both sides, so this will be x power 4 plus x squared y cubed minus y power 5 is equal d over dx of 2x plus 1. Then the second step, we need to differentiate or distribute the operator of the differentiation. So the derivative of x power 4 will be 4x power 3 plus derivative of x squared y cubed, so here we will use the product rule. Derivative of x squared will be 2x multiplied by y power 3 plus, now we need to differentiate y cubed with respect to x, so it will be x squared will be the same, then derivative of y cubed will be 3 y squared multiplied by dy over dx minus derivative of y power 5 will be 5 y power 4 dy over dx. This will equal derivative of 2x plus 1, derivative of 2x will be 2, derivative of 1 will be 0. So now we need to collect the term that contains dy over dx in one side, so this one and this one. We'll move to these two to the other side. So here we have a 3, so we have x squared 3y squared dy over dx, so this will give us 3 x squared y squared dy over dx minus 5y power 4 dy over dx will be equal to, then we move 4x cubed, it will be 4x cubed minus 4x cubed minus 2xy power 3. So we collect all the terms that contain dy over dx in one side and move all other terms on the other side. Now from these two we need to take dy over dx as a common factor. So dy over dx as a common factor, so we left with the 3x squared y squared minus 5y power 4 from here. So here we have 5y power 4 is equal to minus 4x cubed minus 2xy cubed. So the last step, we need to put dy over dx in one side, so that means dy over dx will be equal to minus 4x cubed minus 2xy cubed. We divide by the bracket here, which is 3x squared y squared minus 5y power 4. So the first step, we differentiate both sides with respect to x. So then we distribute the variable, we distribute the operator of the differentiation. So the derivative of x power 4 will be 4x cubed, derivative of x squared y cubed. So here we have two functions, so that means we need to use the product rule between these two. So we differentiate x squared will be 2x multiplied by y cubed, then plus x squared will be the same, derivative of y cubed will be 3y squared dy over dx minus, then derivative of y power 5 will be 5y power 4 dy over dx, which is equal. For this side we have 2x plus 1, so the derivative of 2x will be 2, derivative of 1 will be 0. Then the third step, we put the term that contain dy over dx in this side, we move all other terms on the other side. So then we take dy over dx as a common factor, we left with 3x squared y squared minus 5y power 4. Then the last step, we put dy over dx in one side, so that means we need to divide by this bracket. So the final result here, we have dy over dx. Then we have the part B from this example. Find the slopes of the tangent line to the graph of x squared plus y squared is equal 4 at points corresponding to x is equal 1. So for part A, we find x squared plus y squared is equal 4. We find the derivative dy over dx. For this part now, we need to find the slope at the corresponding to the point x is equal 1. So we'll use part A to find the slope. To find the points, or to find the slope, sorry, at x is equal, so we are given here when x is equal 1, we need to find the slope. So first we know that the slope is dy over dx. For x we will replace x by 1, but for y we need to find it from here. So first when x is equal 1, so at x is equal 1, we have this one. So 1 squared will be 1 plus y squared is equal 4. So that's mean y squared is equal 4 minus 1. So y squared is equal 3. That's mean y is equal plus or minus root 3. So dy over dx at the point, the first one is 1, then the second one is root 3. This will be equal, replace x by 1, so it will be minus 1, divide by, replace y by root 3. Then also we have another point, dy over dx. When x is equal 1, the second one is minus root 3. So this will give us, when we replace x by 1, so we have minus 1 over, then minus root 3. This will give us 1 over root of 3. So we have 2 points, or we have 2 points where the at the point, we have 2 slope at x is equal 1. The first one is minus 1 over root 3. The second one is 1 over root 3. Where the point of tangency, when x is equal 1, we have 2 tangent lines. Let us see this one from the graph. For our function, where our function is x squared plus y squared is equal 4. So here we have the r is equal to, we have 2 tangent points at x is equal 1. The first one we have at the point 1 root 3, and the second one we have at 1 minus root of 3. So this function has 2 tangent line at 2 where x is equal 1, so we have 1 root 3 and 1 minus root 3. So example number 3, find dy over dx if x power 4 plus x squared y cubed minus y power 5 is equal to x plus 1. To find dy over dx, so the first step we need to add d over dx for both sides. So this will be x power 4 plus x squared y cubed minus y power 5 is equal d over dx of 2x plus 1. Then the second step, we need to differentiate or distribute the operator of the differentiation. So the derivative of x power 4 will be 4x power 3 plus derivative of x squared y cubed. So here we will use the product rule. Derivative of x squared will be 2x multiplied by y power 3 plus, now we need to differentiate y cubed with respect to x. So it will be x squared will be the same, then derivative of y cubed will be 3 y squared multiplied by dy over dx minus derivative of y power 5 will be 5 y power 4 dy over dx. This will equal derivative of 2x plus 1, derivative of 2x will be 2, derivative of 1 will be 0. So now we need to collect the term that contains dy over dx in one side. So this one and this one. We'll move to these two to the other side. So here we have a 3. So we have x squared 3y squared dy over dx. So this will give us a 3x squared y squared dy over dx minus 5y power 4 dy over dx will be equal to, then we move 4x cubed, it will be 4x cubed minus 4x cubed minus 2xy power 3. So we collect all the terms that contain dy over dx in one side and move all other terms on the other side. Now from these two we need to take dy over dx as a common factor. So dy over dx as a common factor. So we left with the 3x squared y squared minus 5y power 4 from here. So here we have 5y power 4 is equal 2 minus 4x cubed minus 2xy cubed. So the last step we need to put dy over dx in one side, so that means dy over dx will be equal 2 minus 4x cubed minus 2xy cubed. We divide by the bracket here, which is 3x squared y squared minus 5y power 4. So the first step we differentiate both sides with respect to x. So then we distribute the variable, we distribute the operator of the differentiation. So the derivative of x power 4 will be 4x cubed, derivative of x squared y cubed. So here we have two functions. So that means we need to use the product rule between these two. So we differentiate x squared will be 2x multiplied by y cubed, then plus x squared will be the same, derivative of y cubed will be 3y squared dy over dx minus, then derivative of y power 5 will be 5y power 4 dy over dx, which is equal. For this side we have 2x plus 1, so the derivative of 2x will be 2, derivative of 1 will be 0. Then the third step we put the term that contain dy over dx in this side, we move all other terms on the other side. So then we take dy over dx as a common factor, we left with 3x squared y squared minus 5y power 4. Then the last step we put dy over dx in one side, so that means we need to divide by this bracket. So the final result here we have dy over dx. Number 5, find dy over dx if sine y is equal y cosine to x. So again here we need to first add d over dx for both sides. So here we have sine y is equal d over dx y cosine to x. Then the second step we need to differentiate. Derivative of sine y will be cosine y, but here is a function of y, we differentiate with respect to x, so we need to multiply by dy over dx is equal. Derivative of y cosine to x, here we need to use the product rule. The first function is y, the second function is cosine to x. Derivative of y with respect to x will be 1 multiplied by dy over dx multiplied by cosine to x plus, then we differentiate the cosine, we multiplied by y. So y will be the same, derivative of cosine will be minus sine to x. We need to multiply by the derivative of the bracket, which is 2. So the second step or the third step, we need to write the term that contains dy over dx in one side. So I'll move this one to this side. Here we have cosine y dy over dx minus cosine 2x dy over dx will be equal 2 multiplied by y, so it will be 2, and here we have negative, so minus 2y sine 2x. Then we need to take dy over dx as a common factor, so dy over dx, then here we have cosine y minus cosine 2x. This will be equal minus 2y sine 2x. Now the fifth step is to write dy over dx in one side. So dy over dx will be equal minus 2y sine 2x, and we divide this one by the bracket, which is cosine y minus cosine 2x. Find the second derivative, which is d squared y over dx squared if x squared plus y squared is equal 4. So here we need to find the second derivative. So to find the second derivative, we have seen that from the previous example, which is what it was example number 1, I think. Once we find dy over dx, this gives us it is equal minus x over y. So now we need to find the second derivative. So that means we need to differentiate this one again. So d over dx of dy over dx, this will give us it is equal derivative of minus x over y. So from here, so this is d squared y over dx squared. This will give us the minus, we can take it here. Now the derivative of x over y, we use the quotient rule. Derivative of x will be 1, we multiplied by y, minus derivative of y will be dy over dx, and we multiply by x. Sorry for this one should be dy over dx. So here we have dy over dx multiplied by x, and we divide this one by y squared. So this will give us minus, and here we have y minus x dy over dx all over y squared. But what is dy over dx? We know that dy over dx, it is given by this one, minus x over y. So you need to replace this one by minus x over y. So this will give us, it is equal minus, here we have y minus x multiplied by minus x over y all over y squared. So here we have x, we can take it with, so here we have y minus x over y all over y squared. So writing this one is here up, we get that dy over dx, or d square y dx squared is equal minus, and here we have y, minus with minus will be plus x squared over y over all y squared. Then this will give us minus y multiplied by y, so it will be y squared plus x squared all over y cube. This one is y cube, because here we have x is y squared, and then here we have also y, so this will give us y cube. Now we know that x squared plus y squared, it is given by 4, so this will give us minus 4 over y cube. So this is the second derivative, d squared y over dx squared. So the second derivative is given by this one. You had to, after you find the second derivative, you need to replace dy over dx by the first derivative. So once you rewrite it as a function of x and y only, then you can simplify. So first we have this to find the first derivative. Then once you find the first derivative, you find the second derivative. If you have a term in the second derivative, which is dy over dx, you have to replace it by the first derivative. After you replace it, then you simplify your function. We get here x squared plus y squared. If I write here star, so this one will be clear for you. So x squared plus y squared will be 4. So that second derivative will be minus 4 over y cube.